Hello everybody! Today we're going to introduce model STG and STVT bar EV, respectively, for the gas turbine and the vapor turbine simulator. Each simulator has a bunch of potentiometers and switches to trigger different actions on the simulation itself, and it has a couple of touch screens to see the different values in different points of the circuit. We have to grasp the gist of the simulator. Both the two objects are strictly connected and can be used one per time, but they are strongly connected and paired. This is the turbogas example, allows the student to get familiar with a quantitative approach. You can probe the different temperatures in different parts of the circuit, and you can perform the parametric study while inserting the exchanger, the heat exchanger, and just for example. By regulating the potentiometers, the students can simulate the different amount of air and fuel in the turbine and to see the output of the calculations in the various elements and the attached software. The first part of the study is the on-design phase, in which the students can design the turbine according to specific initial parameters. Then they can toggle the off-design phase, in which they can simulate the request in active and reactive power by an external user. Once certain warning conditions are met, some alarms get raised, and so the student can have a visual indication of what might be the problem. In the software, we see the exact same information as far as the warnings are concerned and the power production. The simulator allows for different parametric studies in which the students can toggle between different kinds of fuel powering the plant and the age of the plant, just to see the evolution in the technology. Then they can simulate the compression ratio and toggling the heat exchanger. So the exact same information you see on the touch screens you got also in the software. And we got a real-time Monte Carlo simulation of the evolution of values. The STVT simulator allows the student to simulate different kinds of steam turbine plants. The controls, the set of controls on board is similar to the STG case, in which we have the regulation of the fuel mass and the water mass that enters the plant, whereas here we have the selector for the different kind of turbines. For example, you can simulate the reheating process, the supercritical case, and the vapor spill. The software allows for selecting the pressure and the various parameters of the simulation, and I can have a real-time visualization of the cycle. As for STG, we can simulate different kinds of fuel powering the plant and the plant age itself. By acting on the potentiometers, the student can regulate the mass of the fuel and the mass of water involved in the process, and monitor the evolution of the system via the two touch screens. As for STG, also in STVT we got an on-design and off-design phase, respectively for the design process and the real-world operation, in which we can simulate the users requiring more active or more reactive power. So, as for STG, we saw before, we can toggle the different and simulate different warnings in the system, which are also present in the software. The two simulators can be commanded by remote without requiring the intervention of a technician in front of the application itself. So The students can toggle the remote control with this button here in the software, and they can change the way the simulation behaves. Now we check the connections for model STG. First we connect the power supply, which is 12 volts, 2.5 amps, on the side of the simulator. Then we connect the USB Type B cable. Then we turn on the simulator, and in the meanwhile, we let the executable run. We select the available COM port, and we are ready to start the experimentation. So today we saw the two simulators, STG and STVT, which simulate respectively the gas turbine and the steam turbine. For all the additional details, please refer to our website, and thanks for watching.